Okay, in this lesson we're just going to take a look at some basic generic patterns that everyone can recognize without really doing much math at all. All we have to do is look for some things that are in place that kind of tell us the structure of this function without really a whole bunch of details involved. Now if you notice on these four functions I've written down, I didn't write anything except the first term, what we call the quadratic term, the one that has the squared on it, because that's what really determines the shape of this thing. Now we've seen before that anything with an x squared, and that's my highest exponent, is somehow going to have a u shape to it. We call it a parabola. Now if you look at the number that goes in front of this, in this case I just have a positive 1. Okay? And anytime I have a positive number, well, I get a parabola that opens up. And what I'm going to do is I'm going to try to compare everything from here on out, the blue, the green, and the orange, all to this one in black, because this is kind of our basic format. If it was just y equals 1x squared and I put plus some other stuff, because there could be some other things there. But if it just has a 1x squared, this is its general shape. Now let's take a look at some changes that would happen. If I look at this equation, the only thing that's different is I have a negative in front. A negative just means, oh, it goes from what we call a smiley face, a smiley function, to a frowny one. It's still the same U shape. It's the same basic width, same basic everything. It just flips to a negative. So it points down. Now what if I have one with a bigger number in front? This is where things tend to get a little complicated. Now when we dealt with linear equations, lines, we saw that the number that was attached to the variable represented the slope. Well, the same is kind of true for these, even though we're not really talking about slope as we know it. But when we think about the steepness of this graph, how steep it is, you can kind of think about 2 being the slope. Okay? So this is positive. It's going to look a lot like the one right above it. It's going to be opening up. However, it's got a positive 2 on it instead of a 1. This one had a 1. So you can see how steep this one was that just had a 1. In comparison, the one that has a 2 would be more like this. Okay? Notice how it climbs at a faster rate, so it's changing really quick. It gets really steep really fast. Okay? If that was a 4 or a 10 or something, it's going to get even steeper, which basically makes the graph really, really narrow, but it climbs really, really fast. Now, let's look in contrast. What if, instead of having something bigger than a 1, we had something smaller than a 1? Well, if we think about this in terms of slope, even though it's not exactly slope as we've studied it, it's basically saying this graph is going to be kind of flatter. It isn't going to grow as fast. So in comparison to this one right here, this would look like this. And what I'm hoping you can get out of this video is that you can look at any equation and notice, see all these dots over here? I didn't write anything there because I didn't want you to get distracted with things that don't really matter. The overall shape of this graph comes from the first term, and it really comes from the number that's attached to it. We call it the leading coefficient. And if you can look at that number, hey, negative tells me it's going to go down. Small number means it's going to be flat. Big number means it's going to be pretty steep. And basically, you get those patterns down, you kind of know where these things are headed. That way, if you have to draw a graph and get specific points, and you get ones that don't match these patterns, for example, you know it should be going down and that's not happening, well, you can go back and double check your math. Maybe you haven't really found the vertex yet. So this is just to give you a basic understanding of all the different possibilities that are out there.